Dr. Marissa May. In this video, we're going to be looking at doing some operations with matrices. Let's take a look first at addition and subtraction. First rule of thumb is before you can add or subtract matrices, you have to make sure they have the same dimensions. So if one matrix has 2 rows, the other matrix has to also have 2 rows in order for you to be able to add them, because you're going to be adding corresponding elements. That means if that element is in the top right, it's going to be added to the other element in the other matrix that is in the top right. Let's take a look at an example with some numbers in it. So if we're going to add these 2 matrices, I want you to notice that the first one on the left has 3 rows and 3 columns. The one on the right also has 3 rows and 3 columns, so we know we can add them. Now, we're going to add corresponding elements. That means that we're going to take the 5 that's in the top left of the first matrix, we're going to add it to the -5 that's in the top left of the second matrix. I like to write it out like this just for my notes' sake so I can actually see the addition. I don't write it for every problem as I keep practicing, but I want one good example where I've written out those additions for my notes' sake. And then I can go ahead and perform the addition. So the 5 plus the -5 gives me 0. The 8 plus the 4 gives me 12. The 12 plus the 2 gives me 14, and so forth. But I want you to see that we're adding the corresponding elements when we're adding 2 matrices. Let's look at one more example here. So I want you to think, you may want to go ahead and pause the video here. Try this one. See what you would get if you add the corresponding elements here. So -1 plus -6, -2 plus 3, 10 plus 2. Write out those additions for yourself so that you can see them. And then go ahead and do the addition. So the -1 plus -6 would give me -7. The -2 plus 3 would give me 1. Again, I'm just very detailed here. Sometimes if I have it on paper, I'm putting my finger on each one of them so I don't lose track of where I'm at in the matrix when I'm adding. Now, subtraction is the same way, but I want you to be careful because order matters when you subtract. And this is where coming and writing it out, write out the subtraction is very important. But first, before we do that, let's check and make sure these matrices have the same dimensions. Both have 2 rows, both have 3 columns. That's important. Now you want to remember you're going to do the left matrix minus the right matrix. So for that first element, it's -1 minus 5, order matters. -2 minus 1, 10 minus 14, and so forth. Once you write those out, then you can easily do the subtractions here to get your -6 and -3 and -4, right? Be really careful with those subtractions, again, because that order does make a difference. Now, when we look at multiplication, that is different. We do not multiply corresponding elements. So the first thing you must check is that you have the columns of the second matrix match the rows of the first matrix. Now that's confusing, okay? So you need the rows of the first matrix to match the columns of the second matrix, because we are going to be multiplying row AB times column EG. That's what we did. We did row AB, so A times E, B times G, and we add them together to get that first element. Let's take a look at doing one like that. All right, I've got -2, -1, -2, 2, -9. I've got 5, 5, -1, 4. So we're going to multiply row -1, -2 times column 5 times -1. So after we look at those dimensions, we see that we can multiply. So I've got -1 times 5, -2 times -1. I'm adding that to go in that first element. I have to do all of that just to get the first element. Okay, then I'm going to do row 2 times column 1. So row 2 column 1 is in row 2, column 1. So 2 times 5, negative 9 times negative 1. I'm going to perform that operation in order to get this element. Let me get my video out of the way so we can see the next one. I've got row 1, column 2. So I've got negative 1 times 5. I've got negative 2 times 4. That goes here. Then I'm going to do row 2, column 2. So I've got 2 times 5 is here. Negative 9 times 4 is here. So I'm performing that multiplication and addition. Multiplying matrices takes a lot of detail, so I need you to be very careful. Take your time. Write out those calculations because you'll make less mistakes that way. Let's take a look at this one. I've got a 2 by 2 dimension, 2 rows, 2 columns. I've got 3 rows, 2 columns. Those don't match. What does that mean? That means we cannot multiply them, right? Those dimensions don't match up. We cannot multiply them. Let's take a look at this one. I've got a 2 rows, 3 columns. I got 3 rows, 2 columns. This one we can multiply. So be very careful. You're going to multiply row 1 times column 1. That's how I got the negative 5 times 8, the 2 times negative 1, the negative 11 times 4. Then I'm going to do row 1, column 2. That's where I got the negative 5 times 6, the 2 times negative 4, the negative 11 times negative 3. Then I'm going to do the row 2, column 1. So that's where I got the 1 times 8, the 3 times negative 1, the negative 7 times 4. Then I'm going to do row 2, column 2. That's where I got 1 times 6, 3 times negative 4, negative 7 times negative 3. Okay. Really, really concentrate on doing row times column on that. Okay. And then do your calculations over to the side after you've written it out. That is what's going to help you the most to do these multiplications with your matrices. All right, some things to know about addition and scalar multiplication is that you can change the order when you add. Pretty simple there on number 1. The number 2 says you can add them in different orders. If you want to add A and B for 2 matrices first, and then a third, that's okay. Or you could switch the order up. For the third one here, that K is just a number that's being distributed to the matrices, okay? And then we say here in the ones for multiplication is that the order matters, right? The order matters when we multiply because we're watching those dimensions.